So now we go what is left of the whole thing. Well, perspective I mentioned already, where I'm coming from. I'm skipping those slides. Yeah. So what you see, hold on, excuse me. Go back. Okay. So there are a couple of type of information in the header. There are instructions for the browser to do something or not to do something, which are useful for the browser in order to render the page, in order to show people what they're looking at, in order to keep the session, which is very important also. But there are also futile informations in there. For example, type of server, the application, version numbers, and all that stuff. You also can get hints regarding the framework. Architecture hints, for example, the via header tells you that there's a REST proxy up front. There are sometimes you see IP of load balanced servers. I give one example over there later on. So what do we need to ask if we are looking at this information is where does it come from, the header? So in a simple picture, like we have a LAMP stack or IIS plus .NET application, which is residing on one physical server. It's very easy. It comes from one physical machine. It comes either from the web server, from the application server, or from the application itself. But this is only a portion of the reality. Another picture is you have a reverse proxy up front. You have an entry web server. You have an application server. And you have an application in the end. So in this scenario, it depends a little bit on the request you're sending to the server side, what you get returned in the HTTP header. With one request, you can hit the WAF or the reverse proxy only. With another request, maybe you're hitting the entry web server, and with another request, you maybe hit then the real application in the end. It mostly depends on the path you supply in the browser in this scenario. So often forgotten is there are also other information in the header and also in the SSL handshake, which you can use for fingerprinting. The HTTP header contains the date. And the TLS handshake, there's a TLS timestamp. Every SSL stack on the server side nowadays, well, almost every SSL stack on the server side does that. For Microsoft, the S channel does it almost all. OpenSSL does it up to version 1.015F. And you can draw a couple of conclusions from those timestamps. First of all, do I get different times if I'm hitting different paths? Then, for example, if I get random times returned, it's a strong hint that somebody's using OpenSSL beyond that version, and a couple of other things. What you can do for fingerprinting on the server side is basically the thing why OpenSSL decided not to include the TSL timestamps anymore on the client side. So this was one of the reasons, because if you with your OpenSSL, with the old OpenSSL client, you hit a server and you're delivering the time to the server and the client hello. So this allows the server side to fingerprint what your time is on your machine. So this is the reason why it's nowadays filled with random values, but from a pen tester perspective, you can also use it for fingerprinting if the server still allows it. So one beautiful example of this is it's a real life scenario. You're looking at the output of test SSL. You can achieve almost the same in principle with Nmap. I don't know whether you see it on the back. I can zoom it a bit. So you see from, oops, I'm sorry. You see the time is off. And the time is off in two ways. The SSL time is off by 159 seconds, and the HTTP time is off by 20 seconds. I'm running, while doing this, I was running NTP on my local machine, so the time is almost accurate. But this tells you, for example, two things. For example, OpenSSL, a node OpenSSL version is used. Then it tells you something about the architecture, which means SSL is terminated at a certain point in the architecture, which is here a web application firewall, and also the time is off there. I don't know whether it's, well, as I said, it's a real life thing. I don't know why they don't use NTP, whether they have a problem with it, but all I can tell you, it's the time is off and it allows you to do some fingerprinting. Oops, okay. Sorry. Good, this is some old fart, but it's still worth to mention for you guys which are not aware of that. There's a cookie from Big IP which allows you to do some fingerprinting for the architecture. It's something that came up like 2010 or 2009, for example. You see a string there which is injected in the HTTP header, which looks like this. And there's a Python script which allows you to decode the cookie so that you can have the private network address and the port where everything goes to. Well, that's known to Big IP, and there's a KB from F5, which tells then, or which shows then how to use AES encryption for this. Similar thing I spotted a while back for a NetWeaver cluster, but there were already the IP addresses in clear text included in the cookie. It was kind of weird. But I didn't know the background of that. I don't know if somebody knowing more about this stuff on NetWeaver? Okay, good. Okay, fingerprinting, architecture, patch level, and a little bit more. That's of course interesting for all people on the dark side. You want to fingerprint all that stuff, but also you have to take into account that if you hide those information, it doesn't necessarily hide you from getting hit by evil folks. The only thing which you gain maybe if you have an old web server that you won't be found by Shodan or by other means. If a hacker is really targeting you, he's throwing everything at you and basically doesn't care what level of web server, OpenSSL, whatsoever you have. So the conclusion you should draw from what's really necessary and what you can done to improve security. If you look at this, now you see a couple of things which you should do and maybe you should not do. Well, is there something which you should do? Well, I take that back. So you see, for example, here the version of Apache which is used. You see here distribution. You see here the module which is being used. You see here OpenSSL. You see here the version of OpenSSL. I made it up, okay? You see there's no, the session ID doesn't carry HTTP only or secure flag. It's an old, very old PHP version that is very dangerous to use because if somebody's using Shodan, is looking for old exploitable PHP version, there you go, right? So you should minimize those information and remove those chatty lines, and also you should also add stuff. This is what the next chapter will be about. I think I skipped that. So let's go into detail with HSTS. Jim, you here? No, he's not here. Who've been in the talk yesterday from Jim Manico? Okay, quite a few. I like to add a few bits to that. HSTS is a standard since I think 2002, RFC standard. So the reason why probably it was became very fast RFC was at Black Hat 2009. Moxie Marlinspike presented a tool called SSL strip. So what that actually does is man in the middle in SSL connection by just talking HTTP to your browser and SSL on your behalf to the server side. So what he presented was kind of smart. He even put log icons so fav icons as with a luck symbol on it, so that people got the user experience. Okay, I'm using HTTPS without looking at the URL correctly. That was kind of cool, and our people showed, oh, okay, what can we do about that? Then 1 year later, an RFC was released in order to provide protection for modern browsers, which was picked up by Mozilla and Chrome. It works the way that once an HSTS header is sent, the browser won't be able to connect anymore using plain text anymore. So the support for the browsers is quite good. So you see this very early version of Chrome. We are now at, what are we, 40-something, 42, 43. For Firefox also. Also Safari, Opera have that on. A little bit what is missing is the Windows side. But yeah, well, we'll see it on a couple of slides from me. So, but there's a catch to the whole thing, which also Jim yesterday explained. If I'm in the middle, if an evildoer is in the middle of a connection, he has a problem, which is vegetarians know this. It's a tofu. It's the trust on the first use principle, because they don't know also if HSTS header is supplied, whether I can trust the site. So then everything was extended, or the RFC was extended with a preload instruction. So for Chrome, you can apply for including your URL preloaded in the Chrome browser using this URL over there. And I don't know how Firefox does it. I tried to find out, but it looks to me like they're... Yeah, yeah, okay. That was my impression too, but I wasn't quite sure, because it was nowhere said that clearly. Oh, sorry. So, but as you can imagine, there's another catch. It doesn't scale very well. You can't put the whole internet preloaded into the browser, because the browser will otherwise explode if you download it. There are a couple of pitfalls, however. For example, let's say you're a startup company, you reserved a top-level domain for you, and you're running your whole business under this top-level domain. Cool domain whatsoever.com. So let's say now your business, and you're one of the security guys. Okay, I do everything which is good for security. I now include a HTTP header with a max age of 180 days. Or even more, 1 year, and your business comes to you and say, okay, I want to have another website which is called this and that and that, and you forgot about that you didn't have that in your mind, but you also include the include subdomains statement in your HSTS header. So what to do? It's really a disaster, because this is the thing which is not that easy to solve. Another thing is there are also two ways to fail if a connection is broken, for example, if for a certificate renewal. So you see a website, which is OWASP.de, which is the German website. We are kind of responsible for it, but we don't host any content there. It's just basically a URL shortener. But we forgot to extend the certificate in time. So what Firefox did in that case, it doesn't do very often hard fail. It does very often soft fails. It does a hard fail. So there's no way for you on the client side now, well, with some exceptions, there's no, for example, for my father, using Firefox, there's no way for him now to get to the site, right? You can click on it, okay, accept, I know what I'm doing. This is a classical example of failed security. We guys should also remember that security is not only about confidentiality and integrity, it's also about availability. So this is where security fails, right?
Is this the reason that Microsoft still has not implemented it?
Anybody, any spokesman here from Microsoft who can comment on that?
Coming in 12, next generation.
Okay. Well, there was supposed to be the preview of Windows 10 should contain it. I haven't researched that. So besides ordering a new certificate, this is a critical thing now because this undermines the whole concept of HSTS. Besides ordering a new certificate and then everything is good, you can set max age on the server side to 0. This is also mentioned in the RFC. And things should work again. At least it worked like a year ago with Firefox. It's not supposed to work with Chrome, at least what the Chrome people are saying. I haven't researched that. That's it. Well, as I said, also be careful if you start something. Be very careful, include all your subdomains and with HSTS. That you should really know what you're doing and have a broad view what is happening the next time frame, max age, right? Sorry. So there's the RFC 7968, which came out a couple of weeks ago, which does take that one step further. HSTS only tells you to use an encrypted connection, but still relies on the correctness of the certificate chain. And as we all know, the certificate system is broken, right? This is when key pinning comes into play. There's a directive which is similar to HSTS, which says just public key pins. The great thing is that you can also try it out, for example, with adding report only, and you have a report URI you can specify, which is basically a JSON post. Allowed are pin SHA-256, well, base 64 strings. I'm coming back to that later. And it's also have a max age and include subdomains statement in there. And your browser is only allowed to connect to that site if the fingerprint matches. I'll show that later. So this sounds not only like a good solution against CAs who didn't understand their business correctly or abused their authority in some way, but also against other state agencies which maybe issued a state fake certificate, which is called as compelled certificate creation attack. By the way, you can spot that with perspective very good. If you go from certain countries to certain sites in other countries, you see that the response of the notaries changed sometimes. It's quite interesting. Okay, there's an exception. For example, local CAs, which are provided by your antivirus software on Windows machines. They have two choices to work on the traffic. Either they provide an additional hookup to the S-channel library, or what they're doing, they provide fake CA, which also intercepts the traffic, for example, for browsers like Firefox or Chrome. So this local CAs are still exempt in Firefox or Chrome. You also should think about bigger companies which use proxies, outgoing proxies from Blue Code or any other vendor. They working with client CA, which provides you a certificate, but they also need to look into the SSL traffic. This won't work otherwise with key pinning. The only theoretical problem is also here trust on first use. Of course, if you're talking about a state agency, of course, also the quality of encryption matters. Not only there, and who is using Linux, by the way? Okay, quite a few. You can compare the whole thing with an SSH connection. First SSH connection to one machine. You do SSH to one machine, and then you see the fingerprint. You can try to verify the fingerprint by some means, and or you don't. You just press OK, as most people do, unfortunately. And then you have basically the certificate pinned in your key store of SSH. So next time man in the middle comes, you see that something is wrong, right? But some people also forget to save the keys on the server side and just reinstall the machine. Oh, I didn't save the keys. So okay, that's another story. Oh, that's supposed to be key pinning HPKP. Which keys? Best is you should use two keys. Actually, my personal recommendation, you should use two keys for your certificate. You should not include any CA, because if there's a problem with the CA and the certificate chain, you're screwed, right? Because this, as I said on one of the previous slides, it's a hard failure. The RFC, it's a hard failure. You can't connect anymore to the site. How you can do that, I don't know. There was some information in the web. I don't know that also max age setting to 0 should work, but I doubt that it works. You know anything about that with Firefox? Whether that works? I haven't tried yet in real life. But again, if it would work, it would make the whole thing basically useless, right? So here's basically what it works. It's a little bit of command line voodoo. Getting to my site, you see here two pins over there. And one pin is basically the backup pin. The yellow doesn't come out very good here. Okay, you see two pins here, and the second pin is the one which I'm using on the command line with OpenSSL just to verify the thing. This is the same pin as this one here, over there, which is actually also the same stuff as the browser is doing. Oh, there you go. Browser support is very good. Don't know so much about the WebKit browsers and about Opera. Again, Microsoft Internet Explorer is failing here. Troy, what do you say? Was it also for IE12 supposed to come?
Allegedly.
Okay. Well, we check. So now comes everything, all what I'm showing here. Oh, I should speed up it a bit. All what I'm showing up to here was now per site, right? Now everything comes per page. X content type options, yes. That was a thing was invented from Microsoft during development of Internet Explorer 8. Up to IE7, the browsers wanted to be smarter than the server. So basically, the web server said, "This is an image. I give you image. It's image PNG." And the browser said then, "Oh, I don't trust you. I'm a robot. I'm smarter than you. I sniff the header, and look what it's really like." Of course, this is a problem, for example, for XSS containing the picture or any other payloads and any other type of documents. This is a good example where machines try to be smarter than another machine, and the whole thing fails. Yeah. Another thing is be careful in your Internet Explorer. I don't know whether anybody is still using it. Well, maybe that was the question was phrased too rhetorically. Is anybody using Internet Explorer? Oh, okay. One brave guy. Well, so don't use compatibility view in Internet Explorer 10 or 11 or whatever you're using, because that is switching back to MIME sniffing, right? You're going back to bad old times. Yeah. Also, talking about content, if people are supposed to display something from the server side, you don't know what the client is doing with their content, whether it's saving, displaying within the browser, or doing anything else. So if you have something which you rather want to have externally displayed and not put a payload in the browser, you should put a content disposition attachment in there. For the brave guys who are still using Internet Explorer, it's also a good idea to include that not so known feature X-download options no open, because that basically hides the open button in Internet Explorer. But, well, this whole thing is not passed by Firefox, but to make the story complete, or to complete the story, there are border cases for Firefox or modern browsers like Firefox and Chrome, where also at least Firefox does some content sniffing. In general, first of all, Firefox does trust the MIME type, okay? So it doesn't want to be smarter than the server is telling the browser. But there are some border cases. For example, what if the server is providing no MIME type? So in those cases, Mozilla decided to be to be a little bit more on the side, okay, on the usability side instead of the security side. It does some MIME sniffing for PDF and for PS, for XML, and for HTML. So. And if that fails, it just doesn't display it. Also, for Firefox, there's also border cage. For example, if the server says it's image PNG, but in fact it's image JPEG, it also displays the image. By the way, forgot to mention, this is also an old RFC. I don't know whether it's HTTP 1.1 RFC, but to sniff the MIME type, if the content type is empty, is basically part of an RFC. X-frame options. Okay, it's against click checking. Everybody knows it. It's a good thing to add. Probably there are a couple of options. With deny, same origin, allow from URI. Allow from URI is not honored by Chrome. best bet is always, if things work and no business reasons are against it, to use same origin. Because also, like, for example, type-to-die backend is a typical example, which does a frame into its own website. If you do deny, it doesn't work at all. XXS protection, there are a couple of values you can add. 0 is off. Don't know when that makes sense, but Facebook does use it. I don't know whether it probably it completely probably shuts off the whole sanitization within the browser for cross-site scripting. 1 is on, means browser can sanitize, but the best thing to do if it works is 1 on and mode like block, which is a hard failure. There's also a report URI which you can report. So if you get if you get attacked, you can look at the output and look where it all came from. Firefox unfortunately doesn't support that yet. Chrome WebKit and also Internet Explorer does does honor that. So, yeah.
This is a header you don't need to send, right? Because it's default on. The existing protection is on by default, so you don't have to send
Well, that change. Well, the sanitizing engine changes from release to release, and I don't know whether you can say something to that. I'm not quite sure whether the 0 switch everything off or leaves the part still valid or not. So it's also very difficult to find out. The best bet is always to use mode block. So one example, for example, is this one. Well, it's there's a report URI. You're using YouTube, and every XSS which goes to YouTube will be reported at this URL. Okay. Oh, content security policy, and less than 5 minutes left. Okay. Basically, that's the. Let's do it later, please. There is, well, basically there are 2 standards. One is the old standard, one is the new standard. Well, the new standard is not standard yet, it's a draft. It's not really trivial to implement. You can't just put somewhere CSP headers in there and hope everything works. I did a couple of projects with CSP, and you really need, well, everybody collaborating with you. It's whether development teams, JavaScript frameworks should support it. Also, what is a pain in the neck are trackers, because they don't care what CSP is, but they really it really bites you. Several objects embedded from third-party sites. Well, as always, is key value stuff. Key is a policy directive, and you also have source values. You can put them together as much as you want. I think I'm rather skipping that due to time things. What you shouldn't do is, there are a couple of things which you should not do, which is unsafe inline and unsafe eval, because otherwise you can just forget to write the whole policy. You might come into situations, however, where you need those at least for specific parts of your website. Also, the nice thing is also you have, especially for testing, as I said in the previous slide, there's also the report only option, which comes very handy if you have, can specify your report URI. So before you put everything in production, you can test it. So there's also an OWASP cheat sheet you can look at. So this is approximately, this is how it looked a while back on GitHub. And in order, I'm showing this just to give you an impression how difficult things are looking like. So there's a CSP, well, version 2 or CSP 2, which is still in draft since some time. It includes a couple of things which are most painful. for people who want to introduce CSP on their website. For example, you have scripts on the websites, and you cannot get rid of the scripts. You can basically whitelist the scripts by two means. One is with a script source statement, and you do a hash over it, or you do a nonce over it. Same is possible with style sheets, and also there are frame managers which basically are the same as X-frame options. So where to set it? Now it comes a little bit, a couple of slides left. There are different things where to set it, or it depends just on your access rights that you have. The head which you have in your head. Are you a developer? Are you just the server guy who's doing stuff? In principle, for possibilities, as I mentioned in one of the very early slides, at application web server configuration, the web server itself, or even more in the beginning, reverse proxy or web application firewall. So what's the best, if you ask me? Well, there are two souls in my heart. One is keep it simple and stupid. Just do it at a place which works, right? As long as the application still works, which you should guarantee. Best, of course, is always at the root cause. So if the application is doing something and you have access to the application, you should do it at the application level, of course. Skipping that. Also skipping that. So now we come a little bit to server-side stuff. I've picked two popular servers, Apache and Nginx. No IIS would be also too difficult to explain right now. Two tasks I have for this. One is minimizing the chattiness, and one is providing additional headers or remove headers, which you have there. For example, chattiness, typical examples I tweaked a little bit is something like this. Here you see version numbers, here you see the operating system, distribution type. Here again, this was this is a WAM stack. WAM stack very often, for example, has the complete header lines in there because Windows people don't know where to tweak those header lines. But also Ubuntu sometimes is not behaving very well. You see very often in the internet also the modules which are loaded, the type of Python interpreter or the version of Python interpreter being used, and all that kind of stuff, which you shouldn't advertise. So just to get rid of the Apache stuff, you just should set your server. The things to blame. Should take one step back. The things to blame here are the insecure defaults. I mean, at OWASP we are talking about insecure defaults since a long time, but every Linux distribution or whatever you also .NET application comes with a full-blown header. I don't know why. So. For Apache, for example, you can just set the server tokens to off. You should also set the server signature to off because there are two types of means, well, at least two types of means fingerprinting the browser. One is also if you hit an error page, then you get also the version number. This would reside then in the server in the header Apache. If that is not enough, Apache can modify the server line itself. You should put in mod security, and you could put anything in there if you want to. If you're a Microsoft guy and want to rather to fake the surveys and want to push up Microsoft a bit, you can also put a Microsoft server in there. So, by the way, for this it's not needed to enable the rules. It's just default there. With Apache, it's not really possible to just omit the whole server line, or with mod security. So just a few statements to give an impression what you can do to add headers. For example, header always set, X-frame option, same origin. It's just an easy statement which you should put somewhere in the virtual host configuration or at a place where you think it's appropriate. You can also do that on a location basis, right? There are a couple of set headers here mentioned, a couple of edit headers, and a couple of unset headers. So unset headers, you move something, of course. With edit headers, you can edit something, which is very convenient if the application supplies something. And two slides left. And the great thing, or one great thing you should add, for example, if you're not sure if the server is talking HTTP and HTTPS, you can also use a environment variable which is called env equal HTTPS. So this statement is only executed if the request is an HTTP request. Same with the secure cookie, because it doesn't make any sense to provide that attribute if the connection is a clear text connection. Also, you can remove any X-powered by header there if you want to. Well, same with Nginx. I'm not explaining that to that extent. Basically, the basic banner is also Nginx 1. Something here. What you should do is putting server tokens off, which does everything for the both header and banner. You can set with there are basically two modules which you can use for edit, unset, or clear headers, or whatsoever. My favorite one is Nginx headers more, which you can also use for just modifying the server banner. You can just also empty the server banner with that statement I mentioned there. And you can add and edit lines, as previously said. Some things, for example, you should rather maybe do at if you're talking about PHP, you should rather do on the PHP ini than to remove the X-powered by banner, because you also need to tweak a few things over there. Yeah, well, final slide. The whole thing is very complicated. Well, you can use your means looking at it at the headers from the outside on the command line. Hold on a sec, please. But in the end, you need to do thorough functional tests, because what I experienced is there's a variety of browsers outside, and not every browser works with every header together. So this is where business really is coming at you and asking what you are doing. Okay. That was it.
Okay, thanks, Dirk, for the insights and practical advice on these headers. We have time for one question, maybe. And Dirk will be around during breaks as well, if you have more.
Hi, thanks for your excellent talk. There are 4 headers that use a report options.
Yeah.
So you can basically do something with reporting. What packages do you recommend, or what software do you recommend to handle these reports?
Oh.
And what do these reports do in the first place?
Well, first of all, you have to, I cannot recommend anything there, because it depends on the environment, what they're using, what kind of framework you're using. Well, there's also external software. There's also...
If my HTTPS fails, I cannot send it to an HTTPS on the same server because it fails. So it's like a loop there. So you need to report to somewhere else, I guess.
Yes.
So is there a service on the internet I can report to? Or?
Well, if you don't care about privacy...
I don't care.
Privacy, yeah. I can't remember the names. There's at least 2 services which provide that kind of things. So you can subscribe to that. I think one was report-uri.io. which is for testing now, and it gives you just then insights what's happening. And the other one I can't remember. But as I said, it's a matter of taste. I would rather go for privacy and do my own stuff there.
Okay, thank you, Dirk.
Okay, sure.